Okay, this is the lesson 4 video, and we're going to start with a question that we went over yesterday that really kind of sets up what it is that we're going to do today. So can everybody turn to that question there? And remember how we did this. We did this yesterday. Everybody should have their books out. Let's go. Okay, so we'll ignore B, because remember B is, that's a SOHCAHTOA question. We could use sine law if we wanted to. But remember for A, what we did is we decided, okay, if we call this angle A, and we call this side A, we call this angle B, and we call this side B, and we call this angle C and side C. If we set up our ratio, and I'll use the angle version, sine A over A equals sine B over B equals sine C over C. Now remember that in this question, you're not actually solving for anything. It just says explain if you can use the sine law. And for this one we concluded yes, and here's why we concluded yes. We know angle A and side A. So as soon as you know one part of the ratio, all you need is a single number in the other parts, and you can figure out the rest. I can use this ratio to find this angle, and then I can figure out this angle, and then I can figure out this side. So the answer was a resounding yes. And then we jumped over to D, or we are going to jump over to D, and for the same thing, sine of A over A equals sine of B over B equals sine of C over C. So let's try this out. Let's see. If I call this angle A and that side A, and this angle B and that side B, and this angle C and that side C, well, let's see. Hang on. Let me go back to my highlighter here. Here's what I know in yellow. I know angle C, and I know angle B, and I know side A. Problem, I don't know an entire side like I do over here, but we had a workaround. What was our way around that yesterday? How did we, if we don't know an entire ratio, how are we going to solve anything? What was our workaround for that? Anybody remember? We can use our 180 degree trick to figure out angle A first, and then we know an entire part of the ratio, and then we can figure out this thing, and everything's good. So those two were both, where's my black pen? There we go. Those two were both yeses, D and C. Okay, let me erase a bit here. The same was not true for C. For C, once again, I'll call that A, I'll call that B, I'll call that C. So that's side A, side C, side B, and I'll set up the ratio. Sine of A over A equals sine of B over B equals sine C over C. Okay, once again, what do I know? I know an angle. I don't know the side across from it. I know this side, I know this side. I'm stuck again. I don't know an entire ratio. Can I fix it like I did on the last one? And the answer was no. Why not? Why can't I just figure my way out of it like I did on the D question? And what was the difference? Why can't I just use the 180 trick again and then keep on going with sine law? And what was the problem?
Because you don't have multiple angles.
The answer is because I don't know more than one angle. I know this one's 100, so I know the other two add up to 80, and I guess I kind of know that this one's bigger than that one. Do you remember how I know that? That was one of our first lessons, right? The smaller angles are across from the smaller sides, and bigger angles are across from the bigger sides. But I don't really know what the numbers are. They both add up to 80, so maybe it's 41 and 39. But that's just a guess. I really have no idea. There's infinite pairs that it could be. So I'm stuck. Unlike this question, I can't get to sine law. There is not enough information to do sine law. So there must be a better way. I feel like I'm selling you stuff on late night TV. There must be a better way. Well, there's a different way. There is another formula, and it looks kind of strange compared to sine law, So now can everybody turn to, oops, can everybody turn to the notebook? And we're going to start lesson 4. Come on, notebook, there we go. And it says cosine law. All right. So here's how cosine law works. To this point, we've examined right-angle trigonometry, right? We did SOHCAHTOA for a class or so to help us solve problems with right-angle triangles. And then we looked at sine law to help us solve certain oblique triangles. Okay, I'm gonna go off the notes here just for a sec. What do you mean certain ones? So which ones can and can't you? Here's how it works. If I gave you, you don't have to write this down, just kind of listen and pay attention. If you had a triangle where I gave you an angle across from a side and then any other, let's say I gave you another side, I would call that, and people who had applied, remember we used to do a big activity about this, we would call this angle side side. And I'm sorry that the acronym's a little bit risque, but that's angle side side. I know an angle and then two sides that are next to it, like going around in a circle like this. And I could do sine law, right? Because I know an angle across from a side. So what if instead of an angle side side, let me erase that. Erase. What if I knew an angle and a side across from it and another angle? No problem. I would call that angle angle side. That works too. So then I could use sine law. What if I gave you an angle and another angle and the side between them? Well, this one would take an extra step, but I could still use sine law. What's the extra step? Well, I'd have to figure out this angle first. So, but I would call that giving you angle, side, angle. Get it? The sides between the two angles I gave you. Any of these three cases, and you can happily use the sine law. But if I give you an angle between two sides, I'm stuck. I can't figure out an angle across from a side. I can't use the sine law. So side, side, and we're stuck. We can't use sine law. So we need a new formula. Notice in this picture, we are given side, angle, side. We don't know a side across from an opposite angle. If I tried filling in the formula, I'd be stuck. Right? I can say, well, I know this side, but I don't know that angle. I know this side, but I don't know that angle. And I know this side, or I don't know this side, even though I know that angle. And there's no way to get one of those other angles using the 180 trick. So we don't have a complete ratio. And because of that, we can't use the sine law. So I would say for the above triangle, we are given two sides and the size of the angle formed by those two sides. And again, in other courses, we call that a side angle side. And when we're given side angle side, we're stuck. Sine law doesn't work. So we are going to use the cosine law. And there's the formula for the cosine law. Now it looks like, oh man, he gave us 3 formulas. Actually, all of those are the same formula. Technically, the cosine law is just one of those 3 lines above here. Do you see a pattern to it? If you look at the formula and you kind of, maybe just for a second, don't do this to your notes, but suppose I just crossed all those out. What do those look like to you? Looks like Pythagoras, doesn't it? And that's kind of what the cosine law is. It's Pythagoras combined with cosine. Do you remember what cosine is? And again, you don't have to write this down. Remember what cosine is from SOHCAHTOA? It's adjacent over hypotenuse. And that should make some sense when you think about it, because if I give you side, angle, side, notice that these two sides are both adjacent to that angle, whereas the sine law, you need a side opposite an angle, and remember, sine was opposite over hypotenuse. So it should make some sense. If there's people sitting there going, I'll never remember which one to use when. Well, if you could remember SOHCAHTOA, you can remember which one to use in sine law. Cosine law is your adjacent one, sine law is your opposite one. And this rule just happens to be, this formula just happens to be what happens if you combine Pythagoras and SOHCAHTOA's cosine ratio. Oh, that didn't work. Hold on. Let me erase all that. Oop, still didn't work. There we go. All right, let's go back to the example. So the cosine law is any version of that formula. And since I'm looking for side C in this example, I'm going to use the C version of it. So C squared equals A squared plus B squared minus 2. In math, this might be news for a few of you. Probably not, though. When we put letters right next to each other and we don't put symbols between them, what are we telling you to do? It's a multiply. So this is negative 2 times A times B times the cosine of angle C. All right, let's put in the numbers. C is what I'm looking for. A would be this guy here, so 17 squared. B would be this guy here, right? So that's 32 squared. Minus 2. Now, I don't like using x for multiply. Sometimes I'll use a little dot. But very often, especially when it's numbers in a row like this, I'll just use brackets. That doesn't mean I need brackets when I punch buttons on the calculator. I'm just using it as a way to write it down so that I don't have x's messing up my work. Because, x means variable when I'm doing complicated stuff in math. And what was angle C again? 105. So that's the way I would write it down. And this is the way I would punch buttons too. Yes, you could figure out what this number is and what this number is and what all of this number is, or just this part and then that number. But I'm trying to discourage people from repunching numbers that they already calculated once. You have a scientific calculator, it knows BEDMAS. I was pointing this out to the morning class. Again, you don't have to write this down, but how many people have their calculator on their phone? Okay? Take out your phone calculator and don't turn it sideways. Leave it not scientific. And do 2 plus 3 times 4 and hit equals. It's going to say 20, isn't it? But if you turn it sideways so that all the fancy buttons come up, and now it's a scientific calculator, type 2 plus 3 times 4, and what's it going to say now? Yeah? So it says 14 when you do it sideways. Now, is the Apple phone giving you a 14 for this one too? Oh, I didn't know that. Okay. My Android one, I'm pretty sure, just gives me a 20 because it's not scientific until you turn it sideways. So when you have a scientific calculator, what makes it this answer instead of that answer? Why is that answer no good? Because this answer comes from, remember this rule? B, what's the next letter? E, D, M, A, and S. Do we remember that from way back? Grade 6 maybe is the first time you heard that? That's the order of operations that a scientific calculator knows. It knows what order to do calculations, and that's what makes it different from just your average, hey, I got this calculator free when I opened a bank account kind of a calculator. So if I have a calculator capable of this, I shouldn't need to calculate all these numbers separately and repunch them. It knows order of operations. Let's use it. Please try to follow along with me, and we're going to punch all these buttons. Okay, so let me move this calculator over to here. Turn it on. Okay, always do a quick check to make sure you're in degrees. And I don't know why it's not turning on. There we go. And do a quick check again to make sure we're in degrees. We are. All is good. And if anybody needs to borrow one, I've got a couple up here. Thank you very much. All right, so 17. Ooh, do you know where your squared button is? I guess we saw that when we did Pythagoras earlier, so everybody should know where their squared button is. Mine's right here. Plus 32 squared, and then minus 2. And remember, I wrote brackets just to make it look nice. It's just a multiply. So times 17 times 32 times the cosine of 105. I don't really need to close that last bracket, but I will just so that it looks nice. And there it is. That should be C squared. 1594.95. We're not going to fall for this, right? We know that's not side C. I dare you to take a ruler and try to make a triangle that's 17 this way, 32 that way, and 1,594 that way. It's not going to work. So what's the last step here? No, it's not going to work. So what's going to happen? What's the last step?
Inverse cosine?
It's not an inverse cosine because I'm not solving for an angle. Look at, the question's telling you, C squared is this. What is it that I actually want? So yeah, the last step is to undo squaring, just like you did in Pythagoras. So this is a square root. And again, don't repunch numbers. I would do it this way. I go second function, and that's where my square root is. Most of you, it's your own button. And then I have to put answer. Some of you don't even have to hit anything. You just hit the square root button, and boom, whatever was on the screen becomes its square root. And there it is. You should get 13 point, I'm going to round it to two places, so 13.9, oops, 13.9, 39, what did I say? 39, thank you, 0.93. And then, oh, careful, if I get to here, I've lost half a mark after all that work. What did I forget? Centimeters, yes, this had units, so the answer should have units. So there we go. That's maybe the most complicated formula we're going to do this year, is the cosine law. Example 2. Okay, this time I want side A. So now I'm going to use the A version of the formula. You can look back in the notes, but I actually don't really have it memorized. I just know how this formula works. I know that if A is on this side, then the next two lines, which are B and C, go here, and then B and C go here again, and then it's the cosine of the angle between B and C, which is always opposite of that. So that's how that formula works. Notice there's kind of a pattern to the formula. And then, once again, let's put in the numbers. Okay, does it matter which one's which? Not really. That has to be angle A, but it doesn't matter which one's B and C, because notice in the formula you're adding two things and then you're timesing them. You can add and times things in any order you want, right? 2 plus 3 is 5, 3 plus 2 is 5, 2 times 3 is 6, 3 times 2 is 6. So it doesn't really matter which one you call B and C here. So I'll put 7 there, I'll put 10 there, minus 2 times 10 times 7. Whoops, I guess maybe I should put it in the same order that I had it a second ago. 7 times 10, not that it really matters. And then the cosine of 40. All right, A squared is equal. Let's try one more time with the buttons. So erase the last thing we had. So 7 squared. If you actually know 7 squared is 49, then by all means you can just punch 49. That's not working. Erase, erase. 7 squared plus 10 squared. And again, if you know 10 squared is 100, you can just put 100. Minus 2 times 7 times 10 times the cosine of 40 equals. And again, that's not how long the side is, that's the square of the side. So 41.75, don't round it yet. A will be the square root of that answer. So second function, square root of my answer. 6.46 centimeters. All right. I'm going to pause the video that I'm making so that people can try the next one without me. Please turn the video back on once you've got an answer. Okay, we're back. Let's see if we've done this right. So, I'm going to call that one A and that one C. If you did it the other way, that's totally fine. B squared is equal to A squared plus C squared minus 2AC cosine of B. So B squared is equal to 14 squared plus 5 squared minus 2 times 14 times 5 times the cosine of 15. So punching buttons. Come on, calculator. There we go. 14 squared. I said squared. Having a hard time. Maybe if I use a pointer here. Plus 5 squared. Ooh, that's working better. Minus 2 times 14 times 5 times the cosine of 15 equals. B squared is 85.77, which is, again, not really the side. It's the square of the side. So I square root to get my answer. Second function, square root of my answer. 9.26 centimeters. Okay, I want to do one little bit different, just to mix it up. I know they gave you a C, and they called that C. I'm going to change that. You know, I'm going to just turn that C into a G. And then I'm going to call that angle G. And then I'm going to call this angle H and angle I. And then this will be side I and side H. What's the formula I'm going to need now? Well, obviously, if I'm looking for side G, it's going to be G squared equals. What's the rest of it going to look like? It's like, oh, but I liked A, B, and C. I didn't have to think too hard about it. Some people have it right away. They figured out the pattern. It's H squared plus I squared, right? The other two sides minus 2 times H times I times the cosine of G. It really doesn't matter what letters we use, as long as you understand how the formula works. Isn't that cool? So G squared is equal to 55 squared plus 40 squared minus 2 times 55 times 40 times the cosine of 95 degrees. And again, notice, this is, how would I know this is a cosine law if I wasn't on the cosine law lesson? Because it's side, angle, side. Sine law would not have worked. So G squared is equal to, let's punch buttons, clear, 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 clear. 55 squared plus 40 squared minus 2 times 55 times 40 times the cosine of 95 equals 5,008.485 and change. Last step, square root. Second function, square root of my answer equals 70.77. Notice there's one other thing different about this question besides the fact that I changed it to GH and I. What else is different? Yeah, this one's not in centimeters. Did you notice that? Millimeters. Good. All right, that's really all there is to the cosine law. It's a really complicated formula, but once you get used to punching the buttons, it works fairly easily. Okay, so now you can try the lesson 4 questions in your workbook. And there they go. I think there's only one page of them. And then tomorrow we'll figure out how to use this ugly formula to find angles. Yee. All right, get started.